Hello, everybody. Welcome to our first ever science fair. This is such a cool, wonderful, unique thing that we're doing. And it's really all because of our intern, Haley.
And
We're so
Andrea.
excited. In case you guys didn't know, Haley has been our intern since, gosh, January, right? Middle of January.
Yeah.
And tomorrow, you guys, tomorrow's the last day of her internship. Ah, but don't worry, because she's gonna stick around. She's gonna stick around and work for us because we love our Haley. So it's the last day of her internship tomorrow. So big round of applause for Haley because that means she gets to graduate college. She's gonna be a rec therapist. We're so proud of her. And the science club and the science fair were Haley's baby project. When she first started her internship, she was like, I think that'd be really fun to do a science fair. And I was like, I don't know, Haley. She had to sell me on it, and it's been so great. So she was right. So kudos to Haley. Good job, Haley. Oh, we have some wonderful, wonderful people that are going to do some great stuff. Haley's going to do an official introduction, and off we go, you guys.
Alrighty. Well, welcome, guys. Thanks for coming to the science fair. So we've kind of been talking about it a little bit, but we have science club members out there, and the last 4 weeks we've been doing different experiments and doing games and activities, and mainly just like learning about the scientific method and how that process works. So today we have our club members, and they're going to be sharing an experiment with you guys. They volunteered to do it, and they picked everything. It was like all of them. We just gave them a list of ideas, but it was all them, and they came up with it and prepared. They practiced for it. It was really great. Yeah, and oh, and also they also invited some of their family, because it's like science fair. Family comes and joins and sees what you guys are doing and stuff. So we have you guys, the participants, and also they were able to invite some of their family to join and watch too. So it's a really big thing for them, and we're so proud of them that they got out of their comfort zone, or maybe they're a little shy, but they wanted to do it, and they're all excited. And so they have a demonstration for you today. It'll be great. Yep. And then there was a few people that came a little bit later. So we'll have the club members, the ones that are demonstrating. So right before you guys start like doing your experiment, I just ask, like, try to do your like hypothesis, try to use your language, be like, if this happens, then, or if I add these things together, then this will happen. And then make sure your camera's on the experiment so we can see what you're doing. And yeah, and you guys are the narrators, so we want to know what you're doing. Yeah, because if we love your faces, we love to see your faces, but we want to know what ingredients you're putting together to make this experiment happen. The conclusion. So, all right, I think that's it.
I have a quick audience note real quick. Audience members, we love you. We really do. We're going to beg that you keep yourselves muted because in case you're not familiar with Zoom, if there's noise in your background, it's all we hear. Even if you're just like moving paper around, it sounds like we're all in a wind tunnel. So please keep yourselves muted. We love the chat. Our participants love the chat. We love to read messages and love about ourselves. So just love on everybody in the chat. We can do fun air high fives and like clappy hands like this after the experiments. That's kind of how we do around here. So please keep yourselves muted. Even if you're like, this is the greatest thing I've ever seen, just show it on your face. We got you. But don't unmute yourselves to share your love because then we can't hear the people doing their demonstrations. Thank you.
Alrighty, so our first experimenter, our first scientist is Michael Keeley. He will be doing a lava lamp demonstration. So take it away, Michael. Take it away, Mikey. You got it.
And you are muted, baby. Make sure you unmute yourself.
I'm Michael Keeley. My experiment is a lava lamp. My hypothesis, my question is, what will happen when I put water, oil, food coloring, and Alka-Seltzer tablets in the bottle? What will happen when I add one tablet or two? I have prepared the first bottle with water and oil. Now I am adding the oil to the water to the second bottle. Now I am adding 3 drops of blue food coloring to the first bottle. Now I am putting 3 things of green food coloring to the bottle. I have learned that oil and water do not mix. Water is heavier than oil. I've learned that food coloring is heavier than water and oil. I am waiting until the food coloring drops to the bottom. Now I am putting 1 tablet in this bottle. What do you think will happen? Now I am putting 2 tablets in this bottle. What do you think will happen? I've learned that this first bottle, it goes a little slower. And I learned that this one with 2 tablets um, runs over, goes a little quicker. Thank you.
Awesome. Yay, good job, Mikey. That was so cool. You did so good. Such a great start for the science fair. It was awesome. That was awesome. Yep. So good, bud. All right. How about we go to the next one? Okay, so next person 2 is Andrea. She'll be doing a Mentos Geyser.
Good evening. My name is Andrea L. Michael, and I'm making a Mentos Geyser. And what do you think that might happen that will make a mess? Let's see what happens. Hold on. Big mosquito. So if I put 7 Mentos in this tube, let's see what happens. Quickly.
Yay, Andrea, that was so good. That was so good. Do we have more or that was good? Is that it?
So in conclusion,
Okay, go ahead.
it did make a mess. Thank you for joining us. And good night.
Awesome. That was so good, Andrea. Yeah, wow, that shot a lot higher than I thought it was. That was so cool. And you were prepared. You have that nice coat. You don't want to get stain. You don't want to get Coke stains on your jacket. Nope. Nope. You were prepared. Awesome. That was so good. Yep. That was so good. Hey, thanks for doing that, Andrea. You were awesome.
Thank you.
Nice work. You're welcome. Okay, so for our next scientist, we have Glenn. Glenn will be doing a cyclone in a bottle. So take it away, Glenn.
Hello.
Oh, you have, oh, okay.
Hey there. I built. Yeah, I know. I built some. I got some 2-liter bottles that have had soda. Emptied them out. Got this connector for the experiment, and I put glitter in the water to make it sparkly with it. And to help me, he make it more interesting. I make sure the glitter is mixed up, and once the idea here is to make a cyclone with this bottle, and once you turn it upside down with the water up, you spin it like this, and voila!
Yay!
I put it in the sunlight to make it more sparkly so you can see it better. This is why I'm out here right now. Fascinating, isn't it? But sometimes there's still clumps from the glitter, so I have to shake it up some more to mix it up. And I think, and that is all for me. Thank you for your compliments, everybody.
Awesome. That was great, Glenn. Very creative with the glitter and putting it in the sunlight. I love that. So smart, so smart. But very good presentation, Glenn. I liked it. Good job, bud. All right, to keep this going, all right, the next person we have Brett. Brett will be doing a lava lamp. And make sure you're unmuted, Brett. And then take it away, Brett.
All right. Hello, everybody. My name is Dr. Brett Brown. So my experience is do my good lava lamp. So, so I'm gonna put some my strength of my one. So first cup of water. See voila. And now let's see what happens if I put green and blue together. First, I do this first. I do this for 3 times. Sorry, let me see.
You gotta open it,
Uh,
see if you can pull the top off. Turn it a little bit.
Yeah. Okay. So let's see what happens if I kind of put
There you go.
this into to my bar.
Good, good.
All right. And now see what happens if I put the green one into the blue. All right. And now let's see what happens if I put this. Yeah. All right. And now the next one is I need to take my glass filled with 3/4 cup of vegetable oil.
Here's what he fix it.
And get my thing to open here. All right.
Good.
Okay, now let's see what happens if I put this in there.
Good.
All right. Okay. And then the next thing I'm going to do is to pour this.
No,
And then,
colored water
oh yeah,
into there.
I need to put some color water into this.
Just do, no, put this in here
So I'm going to put this into here
and
Very good.
not to the top.
and not to the top.
Hold it up a little bit for us, Brett, so we can see. There we go.
Good, stop.
Okay. Let's see what happens.
No, okay, next.
Then the next is I'm going to put the uncut sanitizer. I need to break it into 2 and 3 pieces. All right. Now,
Just one, yeah.
now let's see what happens if I chop this into
No,
my
no,
glass.
break it into 2 or 3
Right,
pieces.
so break it into 3 pieces. So
Good, perfect. Put one in. Okay, hold it up.
I can do hold up for you
Hold it up.
so you can see it. Right.
Put another one in there.
And now I can put the other one into there.
Okay, hold it up. And there is your lava lamp.
And there is your lava lamp.
Awesome! Yay! Great job, Brett. I like how yeah, you added it in one and it was a little slow, and you added the second one and then it came faster. That was so cool. And I love that color choice as well. Nice job,
Thank you.
Brett. You're welcome. You did great, dude. All right, we did have Jason pop in during some of the experiments. So welcome, Jason. Thanks for joining us. We have you on the list. We'll get to you. So what the scientists, what our club members have been doing, they're the narrators. So you just talk us through what you're doing with your experiment, and feel free to share your hypothesis beforehand. And you have a write-up too, so you can use that as a reference if you need. Yeah, but thanks for joining us, Brett. Glad to have you. I'm glad you showed up. It'll be fun. We're excited to see you. Okay. Thanks, Brett. Thanks for sharing. You did great, dude. Awesome. All right, our next our next scientist is a duo, actually. It's going to be Kiefer and Ryder. So the one, I think Ryder's going to be doing half, and then Kiefer's going to do the second half. So take it away, boys. You got it.
We're going to move it over. Yeah, okay. All right. So should we just put him in full screen? And then just write her in full screen? Yeah. Yeah.
We got them both full screen. They're side by side.
Yeah, but we're just going to do one and we have to switch the.
So do you want just Ryder highlighted?
And then we're going to slide the computer over to Kiefer.
Can do.
There we go.
There's a lot of Ryder.
Bingo.
Hey.
Okay. Hello, everyone. For those who don't know me, I am Ryder. We all know how magnets work. But did you know that all magnets have an invisible magnetic field that surrounds all magnets together? So my question is, what does a magnetic field look like? my hypothesis is since iron is attracted to the magnet, when I sprinkle iron filings around the magnet, I think we will be able to see the magnetic field. First, I place my magnet down on this piece of paper. You see? The N stands for North Pole and the S stands for South Pole. Then I place another piece of paper. Oh. I marked N for North Pole and S for South Pole. Next, I take iron filings and sprinkle them around the magnet. That's good. Sorry. Okay, now I gently tap on the paper. And ooh, it's like magnetic magic. You can see thin lines appear. These are the magnetic field lines. Here it's a diagram showing magnetic field lines. A diagram. Our magnetic field lines have some basic properties. They always travel from north to south. They form closed loops. They never intersect. The force is always stronger at the poles because it is more crowded. In conclusion, the iron fields, the iron filings let us see the magnetic field surrounding the magnet, and we can see what they look like. So my hypothesis is correct. And now, a moment from our sponsors. Here is Kiefer to tell us about planet Earth.
Thank you, Ryder. Hello, everybody. Did you know that Earth is a gigantic magnet? let me explain. The Earth's core is made out of iron and nickel. And just like a magnet, Earth has a North Pole and a South Pole. Here the North Pole and near the South Pole and near the Earth's iron core. Whoops. And near the magnetic force field that surrounds it. Earth's magnetic poles are very useful to us. They allow us to use the magnets in compasses so we can find our way to make sure we are heading the right direction. Animals like birds will use Earth's magnetic field to find the right direction when they migrate. And most importantly, the Earth's magnetic force field protects us from the sun's powerful radiation. Here's the Earth's force field, and here is the sun's harmful radiation. When the harmful particles in space hit Earth's magnetic field, they glow. These are our mysterious polar lights that we can see from our north and south poles. Oops, pretty cool, right? So now you know that the Earth is a gigantic magnet. And just like riders, there is an invisible magnetic force field surrounding it. Thank you, everyone, for your attention tonight.
Yay, awesome. Boys, you guys did so good. That was so thought out. I loved it. All your guys's the sheets and everything. It was like we were in a science class. It was like we were in science class. That was so cool. Yeah, Kate, I don't know if you saw it in the chat, but yeah, I didn't know either. I didn't know that the magnetic field was related to like the migration stuff.
Yeah.
Katie mentioned that in the comments, but yeah, I didn't know that either. That's so cool, guys. Thank you for sharing. You guys did awesome. I'm glad you guys came up with that. That was so cool. All right. Yeah. Just so thought out, guys. Good job. Okay, so the next one we have is Rolly. Our pal Rolly. He has a walking rainbow.
I'm
Rolly,
rolling.
you got it.
I'm making water walk to form a rainbow. I take 7 plastic cups.
I don't know how to make it show up.
You're doing pretty good, Kat. It's like if you could go back like a foot, it'd be perfect.
Okay.
Yeah, that's perfect. Yes, 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 yes.
Okay, go on.
I place them in a row. I fill every other cup.
Talk loud, please.
I fill every other cup almost full with water. Then I add 5 drops of red food coloring to the first and 7th cup. Then I add 5 drops of yellow food coloring to the 3rd cup. And 5 drops of blue food coloring to the 5th cup. I stir, then I up the water to make sure all the water is dyed. Then I add folded paper towel cut to size to make a narrow bridge between each cup.
Now, change place.
I see the colors crawling up each of my paper towels. My empty glasses start to slowly fill with liquid. My colors are traveling up the paper towel and blending to make new colors. Red and yellow are combining to make orange. Blue and yellow are becoming green. Blue and red are blending together to be purple. This experiment shows a real life action called capillary action. Capillary action is the ability of a liquid to flow upward against gravity in narrow or thin spaces. The water went up the paper towel and down in the empty glass, combining with another color to make a new color. this is the same thing that helps water climb from a plant's roots to the leaves at the top of the trees. It's also how water reaches the petals of a flower. A walking rainbow is a great way to see how plants live. Thanks.
Yay! Well done, Rolly. That was so good. I'm glad that you did. You showed us the steps of what you did beforehand, and you had it all ready for us to share afterwards. And I love also how you explained the reasoning. You explained the reasoning behind why the colors transferred and mixed, and you related it to plants. That was really good. I'm so proud of you, Rolly. Great job. That was so good.
Thanks.
All right. You're welcome, Rolly. Awesome. Okay, the next one we have Miss Hermanda. Hermanda has something dancing, I think. Take it away, Hermanda.
Okay, my experiment, I didn't really find the real name, so I named it the Magical Floating Marker Astronaut / Man Experiment. My question is, how can I make an astronaut drawing move and will the astronaut that I draw with dry erase markers move if you add water to it? My hypothesis was, I think the astronaut that was drawn with dry erase markers will just get all smeared up after you add the water to it. Let's see what happens. So I'm going to draw an astronaut with dry erase markers on this bucket here. Okay. So so my materials were a smooth surface, dry erase markers, water, and now I'm going to pour water onto my dry erase astronaut man on my smooth surface. Which I want did not work, but my conclusion that I did before was the astronaut was floating on top of the water. And what I learned was that this experiment works due to the insoluble ability of the dry erase marker ink in the water, combined with the lighter density of the ink. I also learned that the density in dry erase markers ink is lighter than the ink in permanent markers, like a Sharpie. Dry erase markers use minimal adhesive, making notes and drawings that you can easily wipe away afterwards. And permanent markers like Sharpies have a stronger adhesive that will permanently stick to any surface you write or draw on. Dry erase markers are also insoluble. That means it cannot be dissolved in a liquid. More importantly, it means it's less dense than water when you pour the water onto the dry erase figure drawing on the smooth surface, making a strong buoyancy force that overcomes the stickiness of the ink, pulling the drawing off the surface and causing it to float on the water. I did this before and it actually worked. Right now it's just making the little things float on top of the water. If you can kind of see. but that's my experiment.
Yay, nice. Awesome job, Amanda. Yeah, so you guys, yeah, it's very unpredictable. That's what science is, right? That's why we go through this scientific method and we try it one way and it'll work. And if we try it a little bit different, just even timing can just like change it. But I'm glad that you just went with it, you rolled with it, and you still finished it out and you told us like what was supposed to happen and you gave an explanation. So good job, Amanda. And if you want, you can also do it again later. You can send us a video if you really, really want to. But yeah, that was great. I love the board. You did just like a real science fair. Awesome. That was good. Yeah, very proud of you. Good job, guys. Or good job, Amanda. Alrighty. Okay, so we just had Amanda. So now we will go to Mr. Alex. Alex has, I believe, an ocean in a bottle. So take it away, Alex. You got it, dude.
Okay, let's.
Good evening. Tonight, I will be doing the ocean in the bottle and in 3 different ways. I have coins right here. I have alcohol. And I have mineral oil and some figures. And even some glitter too. I would like to present this.
Can you guys tip the camera down just a tiny bit so we can see Alex a little better what you're doing? Oh, there you go. Yes, thank you.
2 bottles of mineral oil. Yeah. Okay, careful.
I'm going to put alcohol in. right, now, here we go. That's it. Thanks very much. Thank you.
Yay! Awesome job, Alex. Yeah. So what the two layers, they didn't separate when you were moving them back and forth like that, and it looked like waves of an ocean because the foaminess, kind of like the bubbles, like the salt water. That was so cool, dude. Awesome. Thank you for sharing. I wasn't sure what that was gonna look like, but that was so cool.
Thank you very
Great job,
much.
Alex. You're welcome. Good job, bud. That was so cool. All right, we're coming down to the last few people. So next we will have Miss Janie. We got Janie. She has, I think like a volcano. Whoa, she's got a volcano. Whoa. All right, unmute yourself, Miss Janie, and then take it away.
Hi, this is my science project. I made a volcano out of paper mache and painted it. I tested for lava recipes. My question was, which lava recipe is the best? Hypothesis. I thought recipe number 1 would be the best. Experiment. I test all 4 recipes. Conclusion. Recipe number 1 made the best lava. It worked and made the most lava. I will show you recipe number 1. This bottle is baking soda and glitter. I will put this in the volcano. Do that. This bottle is vinegar. This is dish soap and food color. I'll pour this into the volcano. Yeah, see one. Difference. There it is. Give it a speed. You can see it's good. This is my science project. Yay.
Yay, awesome. So good, Janie. I'm so glad you made that the volcano out of paper mache. That's awesome.
That's awesome.
Wow. It's so cool. It's so cool. Just like an actual science fair.
It's like it. Yeah, it does.
Janie, sit in your chair for me really quick so I can get a little picture of your face.
Yes, sure.
Oh, perfect. Thank you. So good.
So well done. Thank you for explaining and everything. You did awesome. Good job, girl. You're welcome. All right, next we have Mr. Jason. Jason. Just unmute yourself, bud, and then take it away. You got it.
Hello, everyone. Can you hear me? Okay.
Oh, she waved, yeah.
Question, I wonder, what is this? It is a volcano dedicated to Kilauea in Hawaii. I think it is going to produce lava from sodium bicarbonate with acidic acid and water carbon dioxide gives off gas. Now I am going to use my ingredients. First, I'm going to take 2 tablespoons of water. Then 2 tablespoons of baking soda. Two. Then I'm going to add my red food coloring. Very carefully. What? Looks like blood. Dark as this. And then I am going to add my vinegar slowly, 4 tablespoons. One. Two. 3. Ugh, stinks. Yuck. Ugh. 4.
I can hear it.
You could put more of everything back in.
Jason, you can go ahead and you can just dump more of that baking soda in through the top, and then use that water bottle and just keep pouring the baking soda, and it'll just come out. It'll just keep flowing.
Baking soda?
Yeah, go ahead and just dump some more in there.
Sorry, guys.
I think we were kind of wondering about the size of the cup.
No.
Sorry about that, bud. But we'll get it going.
Don't be sorry, Jason. This is science, dude. You are living science right now. You're doing perfect.
Yep, you're doing good. And then go ahead. You can just use that bottle and just go ahead and dump it. There we go.
Oh, it's going.
There we go. Woo! Yay! There we go. Just keep adding more and it'll go. Whoa!
And my
Yay!
conclusion, it oozes.
Perfect. Well done, Jason. Yeah, the size of the cup, I was kind of wondering about the size of the cup, but yeah, you made it work. But that's what science is. You tested something you use those exact measurements and it didn't ooze, but if you just added more, then it worked. So perfect. Great job, dude. Nice just rolling with it. You did awesome.
Thank you.
You're welcome, Jason. All right, thanks for sharing. All right, we
But-
have next our last one for the night. We're already at the last one. Unless I missed anyone. I think I got everyone. Yeah, I checked everyone off. Yep, all right, we have Miss Gabby.
So first you're gonna do is read.
I'm not reading.
Yeah, you have to, so they understand what the process is. Here you go, go ahead and start.
You got this, Gabby.
You got it.
Educate us.
They wanna know what you're doing first.
It's true. Fire is
Did you know?
Did you know that fire is a chemistry invention?
I think I just broke it. Keep reading.
It's true. Fire is a kind of chemical reaction called.
What's it called?
I don't know.
Combustion.
One thing that makes combustion reactions special and sometimes dangerous. It's that they're so.
Oh.
As long as it has these three things below, the combustion reaction will just keep on burning.
Okay, I'm sorry.
The fuel is the thing that burns some familiar samples, but I don't want to read.
So fuel is the thing that burns. Heat.
Yes, fire makes heat, but it also heats and harder burn. I'm bored.
Oxygen. We need oxygen from the air around us. And so does what?
Fire.
Fire. That's right.
Done.
Okay. Okay, so what are we doing here? There you go. Okay, so you're gonna do a color burner, right? Show them what you have.
I need the.
Here's the burner. Okay, and you need you to put your goggles on. Get your gloves because you're working with chemicals.
Mom,
Right, do you want?
Okay, do you want white gloves or blue gloves?
White.
So put on your gloves. I want you to show them what we're using today.
Which one's talking?
You Gabby, try. You don't need gloves. All right, so step one, what are we doing? We've got your,
So
what
what do we
chemicals
have?
do we have?
Gabby, what chemicals do you have?
Show them on the screen. What's that for? That went in.
Huh? Nothing.
No, Abby, you got this.
I talk.
It's okay.
Gabby, you got this, girl. Do you like a silent movie? We don't like a silent movie. We don't get it. You have to tell us what you're doing. You're doing so good.
So this is
Food dye.
No, it's not. Lithium
no,
what?
lithium chloride.
Huh?
So get your scooper out.
You're doing fine, Gabby. You got it.
All right. Your scooper.
Okay, so we got to take this top off. Actually, there you go. Take it off, the whole thing. There you go.
Put it on the side.
Now put your lithium chloride in there.
So,
One scoop. Green. So the glass burner is filled with what? Methanol.
I'm gonna take a scoop.
I'm gonna pour it into the bottle. You want to show them what you have?
Now Gabby's gonna pour it in.
Okay. You would just to do a little bit more, because some of it out there. That's good. Okay. Now you have a
Now we're
stick
gonna
there to
take your
stir it up.
stick, so let's just stir it up. Make sure it's nice.
There's something in here.
What? Why? It dropped in there? That's not good. Get Brooklyn out. Get that out.
No.
We're having technical difficulties. Please be patient. No, I need you to move away.
No
because you don't-
worries. You guys are doing fine.
Thank you. I have to fix this. That needs to be on here like this. This needs to be pulled through. No, don't move it. There, I got it. All right. So, nope, we got that in there.
Have to stir.
You did stir. All right, let's put that right there on top of there. Let's turn this light down a little bit. Let me get a match.
Okay. So make sure the glass burner is filled with methanol. This.
Do you have your goggles on, Brooklyn? Here we go.
Okay, now we're gonna light.
You're okay. That's why we have all of our safety goggles on, right? I'll light it. Ready, Gabby?
Look at that. Ready?
Now watch the flame. That's why we have the water right here. So I'm gonna put the water. Look at that map. Can everyone see it? Not too close.
Yes, we can see it. Oh.
You see the color changing?
It's flashing. It's kind of hard to see the
Changing.
color,
It's
but we can
changing.
tell
You see the
something's
color?
Bring your brightness down.
Bring the brightness down? Okay.
Yeah.
Yeah, it's hard to see on the computer. Nope, too close. Don't lean in.
It is
Changing.
flickering now.
Can you see the color? Color changing flame? So what's the process called, Gabby?
Oh, okay. Yes, I can see it. Yeah, there's like a blue. Yeah, there's like a blue halo. There's a blue halo around it.
Favorite color.
Angle it back up a little bit. I think we could see it a little bit on the top. There you go. Yeah, there you go.
Yeah, there we go. Yeah, we can see it more on the top of the flame when it moves. Whoa, that's so cool, Gabby. You guys had like a whole kit ready. That's super cool.
You need to tell them what you did. Yeah.
Made a color flame.
Yeah.
Made a color flame. Yes, you did. That's right. You mixed those two things or those two chemicals together, and when you lit it on fire, it made that little halo. That was so good, Gabby. Thank you for sharing. You were so brave. So proud of you, Gabby. You did great. You did awesome.
It's watching.
Good job, Gabby. All right, guys. Well, that was our last scientist. I'm so proud of everyone. You guys just blew everyone's minds. I wasn't sure how it was totally gonna go, but we were open and I gave out some suggestions and you guys took it so serious, just like an actual science fair. It was so good. Very impressive, guys. You guys some of you had like like displays. You went through the steps very nicely. You guys had a good voice. You spoke well.
Harry.
What was that?
I'm going to Camp
Not right now, Jeanette. Not appropriate right now.
Right. Like I was saying, well, I'm so proud of you guys. You did awesome. The cute Kiefer and Ryder, so creative with doing half and half and sharing. So that was awesome. You guys had a nice setup. We were able to see what you did. Yeah, I'm so proud of you guys. We applied what we learned from Science Club, and you showed us with your experiments and our you showed our family members and friends what you guys learned and what science was all about. It's trial and error. You try something. We had a few little mishaps, but we just rolled with it, and you still explained it, and you did great. So that's what science is all about. You try something one way, and then it'll work one time, and then if you try it a different way, then it won't, or it will. So very good, guys. Very impressive.
I want to thank you guys so much. That was amazing, and thank you very, very much. Good night, everyone.
All right.
Hey,
Good night,
Jen.
Alex.